Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to Learn with Dummy. Today, I'm going to share how to understand hard concept in a simple way with practical examples that we can use on the job. In this video, we will explore the practical and logical approach to Spark partitioning. Instead of focusing on the technical details, we will focus on understanding the concept logically and applying them in a real world scenarios. This is beyond technical. It's about making data processing efficient and practical. My aim is to make complicated concepts simple and help us all work smart, not hard. Imagine we start a new job on Monday at a New York taxi company. Our task is to analyze and process large volume of trip data. We have been handed this file. What do we do next? Let's walk through it together. This will be our work plan. We will check the system resources, how many cores are available, because it's very important. Understand the data. We really need to dig into the data to make sure what we're working with. Here, we will have an overview of the New York taxi data we will use. Default partitioning. How Spark partitions data by default. Identify how many partitions are required based on 128 MB partition. Custom partitioning, optimizing partitions based on the file size. Cardinality and partitions, importance of cardinality in partitioning, but from practical point of view. Practical example, we will see in this real world application of partitioning strategies. Goldilocks principle, finding the right balance in partitioning, which is very important. So here, you can see I'm working with Windows 11 and I have created the Spark session. Here, I identify the number of cores available for me is 8. Here, I have downloaded the file on my local machine. Just to make sure file is downloaded correctly, I'm just reading the schema, which will give me a bit of understanding on the existing columns. Now, I don't know what is going on with the data, but I know few things about it, that it has 2.9 million records. And when we talk about the default partitioning, this is how Spark partition data by default. So Spark has identified 8 partitions or has done the 8 partitions. One way to look or check the count in the each partitions is this way. So we write this simple code. It tells us here, we see there are 3 partitions with this much data in it. But the total partitions are 8. So let's see what's happening with other 5. So we can see the other 5s are 0. This is not good and not effective way or optimized way. So what we do next? Identify how many partitions are required. As a rule of thumb, Spark suggests 1 in 28 MB per partition. This script runs and it tells us that no partitions is required because the file is too small. Is it correct? No, it's not correct because we have 8 cores available. So we should have 8 partitions. So just one partition should not be done. It's not good. So what next? Next is the cardinality. We need to understand the importance of cardinality in partitioning. Cardinality refers to the uniqueness of values in column. For partitioning, column with high cardinality are ideal. For example, using payment type. Here we can see payment type has 5 unique values, which could be a high cardinality works well, but using vendor ID, which we see here 3, with few unique values isn't effective. Here we can take a couple of other examples. So look at the PU location ID, which has 260. It's too many. So cardinality is very important to check for partitioning when we're working with data. So custom partitioning. Now with very simple code, we can do the custom partitioning. Now we know the vendor ID is 3. So I have tested with vendor ID. It's not gonna work, we know, but let's try. So here we can see it's too many. So one executor has too many. This is too low, and then this is empty. So the vendor ID is not gonna work. I tried with PU location ID with 8 partitions because it has 260. We can't do 260. We look into it in the next videos. Why not? But we just keeping it simple and going here with 8. Here we can see it's not good again because some executors has too many and some has too low. So this will be going really fast and this will be lagging, which is not good again. So we have to go with Goldilocks principle. So what we need to remember, we can't have too many or too few partitions. It's about finding the right balance. This is like Goldilocks principle, not too hot, not too cold, just right. So with this simple code, I'm just doing 4 partitions. Spark by default did 8, left 5 empty. So I'm going with the 4 and it has done a little bit better. It's not perfect, but if we can see the data has been distributed evenly in 4 partitions. So I'm happy with this. I'm going with this at the moment as a first time I'm working with this file. Once I finish that, I just copy into a new folder, data partition. Once it's done, I would like to check the performance. Now, to check the performance, we should go to Spark UI, but we're keeping it simple in this video. So we're just checking. Now, here, what it's doing, that initial data frame ran 0.16 seconds and the repartition data frame took 0.18. So interestingly, while both data frames have the same number of records, the processing time increased slightly after repartitioning. This shows that while repartitioning can optimize resource usage, it doesn't always lead to faster processing times. The result might differ for you, but it shows the code works. This is just to showcase that the code works, but sometimes the partitions may not be optimal. So that's it for this video. Thank you so much for watching. Next, I will be talking about shuffling.